Alright, so let's pick it back up. We have found in this example that there's evidence of a linear relation, and I was looking at a scatter plot, and I would like to have the equation for the line that fits this data. So to get that equation, let's see. We will look for the least squares, squares regression line. So in most algebra classes, you're probably going to see, y equals mx plus b for the slope-intercept form of a line. In statistics, we would, for the least squares regression line, and we'd say y equals b1x plus b naught. So this 0 here, again, that's b n-a-u-g-h-t, naught. The naught is for the 0. So b1 is the slope, and b naught is the y-intercept. So if you had to do this by hand, one way to find the slope, b1, is to take the correlation coefficient, r, and multiply that by the quotient of their two standard deviations, s sub y over s sub x. And then you can use that information to find the y-intercept b naught by taking the average from your y values and then subtracting the product of your slope and the average from your x values. However, again, this can be a little tedious to do by hand, so we're going to use a calculator. And before, when I went to the Stat menu and over to Calculations, I chose option 4 for List 1 and List 2. We actually are given the least squares regression line. The calculator uses A and B, so the slope that's given to us by the calculator in this case was negative 6.295, and so that's the slope, and the y-intercept was 99.3. That's the y-intercept. So if I were going to write the equation here, I would say that y equals negative 6.295x plus 99.3. One more point that I'll make, the notation here, right now I just used a y. Really, in the practice of statistics, I would add a little hat, and we would just say y hat, and that is to distinguish the values that are predictions or estimates based on this linear equation from the values that were in my table that I used to construct this. So these values are actually observations, whereas these values are predictions or estimates. So the little hat allows me to let you know which I'm talking about. Are those the values that I observed in my sample that I used to create the scatter plot and then to generate this equation, or are they values that I've generated from the equation? Alright, so let's say that we want to add this line to our scatter plot. So I go to my function list, in y1 I'll put negative 6.295 times x plus 99.3. Go back to my scatter plot, and now I'm adding the regression line over top of the scatter plot. And you can see that it doesn't go through any of the points in the scatter, but it comes near most of the points in the scatter. And we would expect that when we have a correlation coefficient that's close to either -1 or +1, and we did here. The correlation coefficient was negative 0.9747. So this was a near perfect negative linear relation. So now that I have this least squares regression line, I could plug in different values for x to generate these predictions. And also while we're on this topic, I want to tell you how to interpret the slope and the y-intercept. So the slope, I'm going to give you a little template here. So for every one blank increase in blank, something increases or decreases by blank blank on average. Okay, so there are a lot of blanks there that you're going to have to fill in based on a particular context. So for every, the value, what you'll put here is for every, this is going to be the unit for your x variable. So let's say your x variable was in dollars, then it would be for every $1. Or if your x variable was measured in inches, for every 1 inch increase in, and then you'd have to say what your x variable is, and then this would be your y variable, and you'd choose either increases or decreases. Increases if there's a if b1 is positive, so this would be for the slope greater than 0, and decrease if the slope is negative. And then this would actually be by the amount of the slope, so by b1, and then this would be your units for y. So I'll show you an example later on where I actually fill in some of these values. Now, as far as interpreting the y-intercept, you have to ask yourself, in the particular context of your data, does 0 make sense for x? So if your answer is yes, then the y-intercept, then b naught, is the predicted value of blank. So this would be your y variable when blank, this would be your x variable, you would fill in, is 0. Now, if the answer is no, I'm just going to say don't bother. All right, so that's my discussion of the least squares regression line. So in the next video, we'll look at our coefficient of determination.